Hello everyone, for the last time. This is the final video of our series designed to provide extra instruction for students enrolled in ENGR 467 Real-Time and Embedded System Design. As always, this is Logan, and we are going to very quickly go over dynamic memory usage on the TiVo Launchpad. At this point, I expect you've seen this information enough times, but for those who maybe somehow missed it, course and contact information for myself and Dr. ENGR can be found on Canvas in the course syllabus. To complete the final lab, you must have previously completed lab number 4 and the 3 preceding it. We have only to discuss dynamic memory usage in terms of creating both semaphores and tasks during runtime. Previously, we created our semaphores and tasks at startup using the graphical interface provided by CCS in app.config. Although this works, it's not very efficient in terms of memory management. The memory we reserve in the heap for those is never released, and it could not be used for other processes if needed. Today, we will be dynamically creating those objects, meaning the memory will not be reserved for the entirety of the program's duration. Doing this requires additional considerations, however, such as making sure to delete objects, as failing to do so will cause a runaway memory leak and poor program performance. If objects are not properly deleted, the memory used by them will not be released. In more complex programs, a memory leak is even capable of completely freezing up the application, as no more memory is available to be used. To dynamically create tasks on the TiVo Launchpad, sysbios provides two methods, create and delete. Simple as they are, these functions are quite powerful and allow us to specify parameters such as heap size, initial values, and more. In your lab manual, you will find the procedure to do this rather straightforward. The last thing I'll discuss today is the Runtime Object View, a tool provided by CCS that allows us to observe the state of the TiVo microcontroller. It can be used to watch memory usage in real time and utilize breakpoints in code to see what's happening at specific points. Using this tool is not necessary to complete the lab procedure, but will provide you with additional information and understanding. If you encounter problems, such as the ROV hanging on waiting for program symbols to be loaded, shown here, move on to the next part of the lab. Proper completion of both Part 1 and Part 2 will have the LEDs blinking in sequence as they did before in lab number 4. This is shown here again for your reference. You've now successfully blinked an LED in an impressive 8 different ways, give or take, each more complicated than the last. Congratulations! This brings an end to this video series. Thank you for listening, and I hope it has been useful for completing your labs. Let me remind you to download and complete the lab manual and submit both it and your main.c to Canvas for marking before the deadline. Good luck, and I'll see you another time.